The number was wrong.
16.4.
That was the first clue, the little piece of grit that kept catching on the tongue of everyone who looked at the data, the tiny burr that made a clean narrative snag. A patch of sky no one had reasons to love. A survey telescope on a Hawaiian night pressing its glass against the dark and doing what it always does best: counting photons, laying them into neat columns, turning the chaotic rain of the universe into integers that engineers can respect. The Pan-STARRS pipeline sees something that should not be there.
It flex it. The System catalogues. The human beings look.
They add it to the list with a workman's shrug.
They note the time. They note the place.
They write down what the instruments saw as magnitude 16. For at a distance of about 400 million kilometers. They jot, almost as an afterthought, the part that will keep them up later: interstellar. Third, they say. The third confirmed visitor from the outside. After Oumuamua, the rumor that turned into a rock we never quite understood, and 2I Borisov, the quieter, more classical comet that soothed us into thinking maybe the weird one was a fluke. 3 is the beginning of a trend, or at least the beginning of a reason to sit forward in your chair. They nickname it Atlas because the survey that tripped over it has a sense of poetry when it can get away with it. The name fits whether you like myth or mechanics.
A thing from elsewhere.
A thing that carried something on its back across a gap measured in light years. A thing suddenly in our backyard. At first, nobody needs a story. There is a comfort in the routine of the early hours. You check the calibration. You check the ephemeris. You check the weather logs and the instrument logs. You turn the crank on all the same questions and you get the same reassuring answers. Then you look again at the light. You look at the brightness and the distance and the angle and the way the numbers marry and the way they're supposed to marry. You remember the two variables that own almost everything about how bright a dead rock should look when sunlight kisses it from far away: size and albedo.
How big is the thing?
How well does its skin bounce light back? We have played this game 100,000 times. Small objects are dim. Large objects are bright. Add a veil of dust and you can cheat a little, because a cloud of powder is a better mirror than bare rock. The arithmetic is old, and it is reliable enough to build careers on. Then Atlas ignores it. It gleams like a polished coin flicked into a room that should be dark. It is not a whisper. It is not a maybe. It is not the kind of anomaly you can knock on the side and hope it stops rattling. It's much too bright for the size it's supposed to be. It's much too bright for the tired old rules to fit. In the comparison nobody can resist, Borisov, which was big by the standards of objects we sniff from beyond our sun's fence, barely made itself a smear at similar distances. Atlas shines like it hasn't gotten the memo.
Not a little brighter.
Not a rounding error brighter. Bright in a way that makes the word hundreds useful. So you do what you always do. You bend the hypotheses until something gives.
Perhaps it's a giant, somebody says.
20 kilometers across.
30.
A bulk that would make the statistics blush, because that kind of thing should not wander in often enough to be the third of anything. The models grimace at you. If it's that big, it has no right to be here now. Your sample size is too small to make it comfortable. Anyway, the data points arranged into a story like that do not line up neatly on the line.
Then you chase the dust.
A coma can make a small object look large. The sun tickles the ice and volatile molecules in the skin, and the surface spits gas that drags dust into a soft halo. It doesn't take miracles to get a good glow that way, it takes heat and time, and the solar system provides both. You pull up the spectra and squint. If there's a decent cloud of dust, there should be the fingerprints of gas that help drive it: CO in the cold, H2O closer in. But the spectrographs, those brutally honest machines that do not care about your feelings, report nothing.
No CO. No H2O.
No gas at all, just light that somehow is too strong for where and what you told yourself it was. This is where the discomfort blossoms, not as a scream but as the opposite, a silence you can hear. The excuses we love most get their turn under the lamp.
Dust. Calibration. Background. Misclassification.
Then you ask yourself the thing you didn't want to say aloud, because it sounds tired already and you have a reputation to keep: are we certain this light is only reflected? Have we made ourselves forget that luminous things in space can be small and still shine because they're hot, or active, or built? There is no final move here. There is only a pile of arguments that feel like they belong on different sides of a canyon. Conservative voices say that invoking exotic explanations before you have beaten to death the boring ones is how we make fools of ourselves in public. They are not wrong. Boring is where the truth lives more often than not. Other voices, no less careful, say that boring has to earn its place. It does not get a free pass. If the evidence for the dust is not present in the spectra, dust does not get to sit in the big chair. If the size required would be a statistical outlier so severe that you would throw it away in any other dataset, size is not a gentlemanly answer either. Someone brings up Oumuamua again, as if it were a person at a party who told a story so outrageous that the room alternately leans in and leans away. Remember how it brightened and dimmed as if it were shaped like a cigar nobody believed could exist, and remember how it sped up a little as it left like a ship that had cut its engine too late. Remember how we argued. Some said outgassing without gas. Some said sail in a voice that made half the panel reach for their cups. Avi Loeb is the name that changes the posture of the room. If you know him, you know why. If you don't, the quick version is this: a Harvard astronomer with a habit of saying the quiet part out loud. Oumuamua might have been artificial, he suggested in a book that made more headlines than Friends. The reaction split along the usual lines. Those allergic to embarrassment rolled their eyes. Those allergic to the false safety of polite silence nodded, because someone had finally put into print what they had whispered over coffee with only the curtains for witnesses. He looks at Atlas, and he does not name aliens. That is a caricature of his habit. He points at the brightness and the decay of that brightness with distance, at the way the curve drops like r to the -4 when a hand-me-down comet should obey the easier relationship and fall like r to the -2. He points out that the lack of gas and the presence of a steep light curve work better if the source of the light is not a cloud around a cold rock but a small thing with an engine in the middle. Engine is a dangerous word here.
It conjures the wrong pictures. All he means is a source.
A working center that makes photons without needing the sun to spark the show. He calls it a central emitter. He adds what calculations can be added and says the numbers fall near 10 gigawatts, something like 10 nuclear reactors worth of power. That figure is too round to be gospel and too large to be a shrug. If you want to stay in the natural world, there are boxes to open that do not contain conspiracies. Perhaps it is a shard from a supernova with radioisotopes so fresh they keep it aglow. Perhaps it's a body whose surface electric properties make it a better mirror than any albedo we have assigned. Perhaps the outgassing produces tiny grains we cannot sniff easily, and those grains scatter light far better than we are used to.
Perhaps.
Each line of natural explanation is a thread someone needs to follow to the end.
You keep pulling.
The trouble, for now, is what sits at the end of each. Not a knot, not a bow, but a question mark. The radioisotope story requires a rarity so grand that you feel mathematically impolite invoking it for the third interstellar object we've ever caught. The ice grain story requires the gas that is not there. The supermirror story asks you to invent a surface we have not measured in any lab and bless it with the exact right angle of arrival and the exact right dance with the sun. You can do that. People have gotten Nobel Prizes for doing that, when the end of that path leads to something that predicts other things and survives the winter. Just now, for Atlas, those paths do not shepherd you cleanly to a place where you can put a period at the end of the sentence and leave it there overnight.
Here is a part out of the telescope and inside the human animal.
When there is a vacuum of interpretation in the middle of a public conversation, the universe abhors it and will fill it with whatever it finds. Dust becomes the stand-in for we do not know and we do not wish to be yelled at.
Dust never sues you for defamation.
Dust never calls your department chair.
Dust is tidy.
It is also lazy when the instruments that would reveal it shrug and show nothing. Some of the most respected people in the field say it anyway. They do it because they know how ugly the alternative is, not in the sky but in the room. If you speak the words central emitter without 100 pages of math behind you, someone will write your name on a whiteboard under theories we do not entertain. That is not science. That is sociology around science. It is real, and it shapes careers, and it is partly about caution and partly about fear. On the other side of the wall, the public does what the public always does. It takes the official caution for a verdict, because caution sounds like closing. Then it gobbles the loudest headline it can find instead, because sometimes at least the loud things are exciting. Alien ship, somebody writes. Daily readers click not because they believe but because they want to feel the warm, childhood surge you get when the sky is not just winds and weather but imagination. Serious journals do the opposite. They avoid the A word so hard you can see the outline of it in the empty space around their paragraphs. Their careful language wins the respect of people who respect careful language. It loses everyone else. Between those two parrots shouting ship and dust, the honest box sits there, heavy and quiet. In the honest box is a set of facts that do not play nice together. Brightness that shames our expected albedo at that distance and that size. Spectra that deny a coma's gases. A light curve that drops like a self-lit thing shading itself as it rotates. Calculations that make energy numbers too fat for comfort. And a trajectory that refuses to be as messy as it should be. Trajectories tell their own stories. The way an object moves through a system announces where it came from and what it loves. Most interstellar guests, the very few we've seen, slice through our plane like arrows fired from a balcony into a room full of dancers. They enter high or low, cross the ecliptic once in a hurry, and then go. Oumuamua was like that. Most of the sky should be like that if bodies come at us from a galaxy that does not care about our geometry. Atlas is not like that. It glides aligned with the ecliptic in a way that makes even conservative people raise an eyebrow. Not exactly flat, not so neat that you can call it a highway, but close enough to earthbound metaphors that you get in trouble. Over the months to come, its path will pass within less than an astronomical unit of 3 different planets. You could throw a 1,000-sided die and not get the same number 3 times in a row. You could try anyway and claim that unlikely things happen sometimes, and you would be right. Unlikely does not mean impossible. But if the whole case against wonder is unlikely things happen, you do not have a case. You have a way to delay the harder work. When Scott Shepard stood up at a conference in 2021 to talk about a family of bodies like Atlas, he did not make a movie out of it. He did not say anything you could paste on a thumbnail. He said that in the data there were little shifts. Changes in orbits that did not behave like the pure arithmetic of planetary gravity alone. Non-gravitational accelerations, we call them, in a tone that tries to keep the drama out and the truth in. We've seen such things before. Oumuamua left us with a tiny push we could not fully explain without invoking a coma we could not see. Some liked the story of hydrogen ice sublimating invisibly. Others liked the story of sunlight pushing on a thin body like a sail. Like is a dangerous word in science.
It should be exiled.
But this is a story, not a grant proposal, and liking is part of being a person faced with choices none of us can test in a basement. Atlas makes you think about Tabby's star, the one that dimmed in fits and starts until newspapers filled the gap with the only metaphor anyone in the culture knew, megastructure. When the data refused to vibrate to the tune of any normal explanation, the field bent itself around dust again, confessed that the dust did not fit cleanly, and kept its hands around the teapot anyway. It makes you think about TYC 8241-2652-1, the young star whose debris disk simply vanished on a timescale that the models would never have allowed if the models had been asked before the sky was loud. Someone said planetary collision, and then later someone else said not so fast, and the whole case was folded away into the drawer labeled awkward. We are exquisite at minimizing what scares us. We couch the odd in adjectives that domesticate. We move on because we need to make dinner and write code and take our children to practice.
Inside the small room where the mat geht stone, the specifics get sharper.
If a reflected light object dims with the square of its distance because sunlight thins out that way, and if a dusty coma adds a second power because the cloud itself grows and thins, you can account for some of the slope with geometry. Atlas is too steep. As the distance changes, the brightness falls closer to the 4th power, a clean, nasty drop that screams about a source that is not just sunlight ricocheting off a dirty ice ball. A central emitter helps. Turn that source slowly. Let it present different faces to us over hours and days. You get a light curve that finally looks like the math finds it pretty. That is not proof. That is not the gavel coming down. That is the difference between hand-waving and building a staircase you can climb without tripping. If the center is bright, what is it? You can invent 1,000 small engines that do not need alien hands. Radioactive decay is a sedate, honest source. It is terrible at being that bright unless you put a heart of freshly minted, short-lived isotopes there. Supernovas make such hearts. They do not, as a rule, glue them neatly into pebbles and then throw those pebbles at us on schedules that make the word third comfortable. That does not mean it cannot happen. It means you start to stack improbabilities like chairs and hope the stack doesn't wobble when someone walks by. If the heart is not natural, then we have the other problem, language. A central emitter that is not a natural fire reads to the public the way a red cape reads to a bull. We hear device and jump to civilization because our minds crave mirrors. We skip a dozen steps and go straight to the story that movie posters have been printing for half a century. We are bad at leaving the middle of the possibility tree alone. We are as bad at it in labs as we are in living rooms. A better habit is this: we say what the data will not allow and what the data allow, and we put the words for now in a place we can see. When the brightness first landed on feeds, the difference was stark. Some outlets ran the boring headline, "Unusual Interstellar Comet."
They slept better.
Others ran the one you could feel in your gut, "Possible Artificial Object." They went viral. Neither did the work. Neither respected the place where we actually live, which is the ice field between assumption and fear. In that field, you take careful steps. You examine more spectra. You look for gas in bands you might have missed. You run the photometric reductions twice and then again. You call a friend at a different instrument and ask if they would mind looking. You sit with the idea that if this keeps being what it looks like, you will have to say a thing in a tone that keeps you employed and keeps your soul. One of the worst lies science culture tells is that we are indifferent to reputation.
We are not.
We are primates with degrees.
Wie Kollest Status.
We avoid embarrassment. We weigh the risk of saying something uncomfortable against the risk of never saying the thing that would have pushed the field into a new room. Vera Rubin did not win every argument she deserved to win on the timeline she should have, not because the math was weak, but because minds were. The dark matter curve looked like nonsense until it looked like the only way to make the rotation of galaxies behave in a universe you can live in. We are still not reconciled to what that acceptance bought us and stole from us. We have a similar feeling here. Nobody is claiming that Atlas will be our dark matter. We are saying that the choice is old: paint over an anomaly with diagrams, or admit it is an anomaly and build new diagrams. In the weeks after the detection, you watch the way a culture breathes around news like this. Forums light with threads that begin politely and descend into name-calling because written language is bad at showing whether you are excited or cruel. People with genuine interest ask genuine questions and are shushed because someone else has heard those questions too often. People who want attention write something inflammatory and get it. Somewhere behind all that noise, a graduate student who will be famous or forgotten in 20 years opens a notebook and scribbles a model that actually fits. Somewhere else, a mission planner writes up the tiniest proposal to point a narrow slice of telescope time at a sky that is too busy to give it. The friction between those quiet moves and the loud ones is where real cultures either mature or rot. Atlas, by simply being bright where it should be shy, tests more than our optics. It tests whether we can handle the smell of discomfort without spraying deodorant on it and walking away. It asks whether we can say we don't know, and let the words sit in the open air long enough to draw funding and attention instead of derision. It is not just an object, it is a mirror that reflects the shape of our fear. That shape becomes clearest when you talk about trajectory. Alignments wake a very old part of the brain that wants to see purpose in paths. Physics punished teleology out of us in school, and for good reason. Planets do not revolve in order to do anything. They revolve because forces and initial conditions tell them to. We should not pretend otherwise. But we also should not pretend that purpose-like patterns in motion are out of bounds as categories of observation. If an interstellar body shows a path that minimizes plane changes and maximizes time in the thin ribbon where all the heavy rocks are dancing, you note it. You can note it without calling it a plan. You can say that the coincidence is so sharp that, if this were a clinical trial, you would not let yourself just say chance and go home. The point is not to personify rocks. The point is to keep your good habits when a dog barks in the night. Numbers make habits easier. Less than 3% of interstellar object simulations end up moving along paths like this. Throw in the light without gas. Throw in the decay like 4. Throw in the upcoming close brushes with 3 planets within less than 1 astronomical unit. You can keep throwing. At some point, you have built a pile of unlikeliness large enough to be a mountain. You can climb it and claim victory for boredom. Or you can stop halfway up and say to your friends, look, even if every stone here is innocent, we owe ourselves a better theory of how such piles happen. It is not all theory. It is also measurement and schedule. There are dates etched into the calendar now that give people a reason to pay attention. The next observing windows. The moments when brightness should do this if it's a reflector and that if it's a source. The fingers crossed weeks when Schumann resonance stations happen to be quiet and then not in ways that let us tell whether the planet's own electromagnetic heartbeat notices Atlas at all, a long shot but one that will cost us nothing to look for.
The times when a big radioteleskop ken spare alobe for a narrowband listen just in case.
The times when optical polarization might betray surfaces smooth or rippled or engineered. If you have ever taught high school physics, you know how to speak about albedo without making it sound like a slur. You bring a white sheet and a black sheet, a lamp, and a cheap sensor. You show that some surfaces send light back like a bully, and some swallow it like a library. You map what that does to apparent brightness and why distance matters. You draw a square on the board and tell them that when the square gets farther from the lamp, the light spreads out and the square gets fewer photons per square centimeter. That's your -2. Then you throw chalk at the class to keep them awake and tell them that when a cloud develops, it adds complexity.
More scattering. More area.
Usually more brightness, not less. If your object is getting dim very fast anyway, you have to look somewhere else. You do not need calculus to follow. You just need an honest map. Honest maps will make enemies in the places in you that want closure. They will make friends in the parts of you that signed up for science because you loved the feeling of standing at the edge of something and not flinching. There is a cultural thing here worth saying out loud. We have lived for decades in a romance with certainty. The internet rewards certainty. The admission, "I'm not sure yet," reads like weakness unless you wrap it in moral certainty about unrelated topics. Atlas drags that old bad habit into the light. You can watch in real time who wants a confident story more than a true one. The close readers keep asking about the 10 gigawatts. That number is sticky not because it is precise but because it has the right order of magnitude to push psychological buttons. 10 gigawatts feels like a dam. It feels like a city. It feels like a line crossing from natural into something else. It is hard not to imagine a reactor. If not fission, then what? If not what we know, then what we don't and what we might one day learn to borrow. The engineers get excited in a way that is its own danger. They begin to sketch in their notebooks the way we could beam energy at ourselves in a century if dust and spectra and light curves turn out to be breadcrumbs instead of noise. This is not all bad. Dreaming forward is how we build anything. But the voice in the corner reminds us that drawing stations on the moon in 1958 did not put stations on the moon in 1959. It put a man in a room who argued better for them in 1961.
Patience and posture again.
People who prefer philosophy bring up the larger mirror. If this is artificial, then we are not alone. If it is not, then nature is stranger than the last decade of our textbooks allowed. Both outcomes do something to you. Neither lets you keep the old arrogance where we are central, mature, and masters. Atlas is a cure for the vanity that creeps into our species when we measure our progress in microchips and forget that our maps end right at the edges of our own system. It says, very gently and very loudly at the same time, "You have just begun." You do not have to pick a side between fear and hope when you hear that.
Hope is not a promise. Fear is not a plan.
A better instinct is to move your hands. If you run a telescope, point it. If you write code, write a cleaner light curve model and release it open so that another person halfway across the planet can prove you wrong in a way that teaches you both something. If you teach, say the word unknown to your class in a tone that makes them lean forward instead of smirk. If you write without the tricks that trade honesty for click-through. If you are just a person who loves the sky, keep paying attention. Keep asking why a sentence like "we don't know yet" feels more radical than most of the nonsense we throw at each other online. There are soft, human moments in the middle of this, and they are worth honoring. A technician in a lab far from any headline stares at a monitor and realizes that the calibration she did last week ended up mattering to a question people will argue about for a generation. She goes for a walk outside and looks up and thinks for the first time in months about the way the stars look when you aren't measuring them. A kid in a small town watches a video about Atlas at midnight on a phone and then goes outside and cannot see anything, because the sky is wrong in his neighborhood, but he stays outside anyway. He returns inside and reads about magnitude and distance and thinks the words are magic. They are not, but they might as well be. The middle of the debate is where you find its soul. One camp says that we must not entertain the artificial because it corrupts our thinking. They say the word aliens like a curse meant to protect the city. Another camp says that we must not abort a good hypothesis because the loudest fools enjoy it too much. They say the word aliens with a grin, which does not help anyone's math. The discipline you want is the one that can say engine without summoning a saucer, and can say dust without using it as a shield against the ache of embarrassment. You can choose metaphors carefully to keep the AI voice that will read this from tripping over itself. Think of Atlas not like a ship, but like a lighthouse in the fog whose origin is unknown. Think of the light curve not like a heart monitor, but like a dimmer switch turned by a hand we cannot see. Think of the spectra not like an MRI with the wrong contrast, but like a recipe that is missing two crucial ingredients. The mind likes these analogies. They are not literal. They can live on your tongue without hardening into dogma. Every now and then, you get a line from an old paper that whispers across years into your ear just when you need it. Absence of evidence is not evidence of absence. It is a phrase abused by every crank trying to sell you a miracle. It is also a true thing at very specific moments, and this is one of them. The gas bands are not there. That is the absence of evidence for a dust-driven coma. It is not evidence that a dust-driven coma cannot exist under conditions we do not understand. It is also not a free pass to keep saying dust, because someone will call you reckless if you stop. The spectra are what they are. Your ethics are what you bring to them. Sooner or later, you will have to decide what counts as enough to change your mind. The field does this all the time in smaller rooms. We move priors.
We update.
We grudgingly admit that an old comfort must be left in the hallway while we enter a newer discomfort that fits the facts. When the rotation curves of galaxies refuse to obey the predicted fall-off, we learn to say dark matter like a prayer we still do not understand. When the expansion of the cosmos refused to slow the way smoke in a room slows when the windows are closed, we taught ourselves to say dark energy in a tone so neutral it hid our awe. In both cases, we chose to believe what the instruments told us because that is our religion when we are at our best. We can be at our best again. Between now and the day Atlas rounds the sun and slips away toward whatever emptiness called it to us, the plot will thicken in tiny increments. Photometry will roll in from observatories that owe us nothing. Students will sit up too late trying to curve fit their way into sleep. Grant panels will argue about whether an hour on a flagship is worth spending on a thing that could be dust and shame them in the winter once the romance has faded.
That is fine.
That is how this always goes. There will be noise from other kinds of rooms. A YouTuber will tell you that this is clearly a probe. A skeptic will tell you that only an idiot bets against dust. They will both get paid in their own currencies for telling you what to feel. You are allowed to ignore them. You are allowed to sit with your own questions and take your own notes. You are also allowed to feel the parts of you that are most human lean toward the sublime. An interstellar object wandering through our system with a light that looks internal is a gift whether it is natural or not. Natural means that the cosmos still has tricks to show us we have not discovered, and we get to write about them in textbooks that will outlive us. Artificial means that someone else somewhere has managed engineering in a way that makes our plans look like knotted string, and that we were here to notice it. Both are versions of the same sentence: don't get small. On days when your head is too full, you can come back to one simple rule.
Follow the light. Watch it with machines.
Listen to it with minds. Do not insult it with metaphors that get in the way. Do not rush it into a box that was cut for something else. Do not be afraid to say tomorrow that yesterday's favorite explanation has died a good death. Explanations are not people. They do not need eulogies. They need replacements. All of this grand argument will be built on an unglamorous foundation: observing runs that start at cruel hours, calibration frames taken with the patience of saints, pipelines maintained by the kind of programmer who fixes bugs nobody else saw, time on instruments argued for by people who could have spent their life writing easier proposals. A civilization that wants to catch real anomalies must decide again and again to fund boredom, so that astonishment can sometimes slip through the door. That choice is unromantic. It is the most romantic thing we do. It is not just space nerds who are touched by things like this. The discourse about Atlas has already dripped into living rooms where nobody knows what albedo means. People watch videos that begin with the word impossible and end with the word subscribe, and they roll their eyes and still watch to the end. They argue at dinner about whether we even should search for signs of other engineering out there. One says it is arrogant to assume we would find any. Another says it is worse than arrogant to pretend we are alone because that story is easier to sleep under. A 13-year-old says nothing, goes to her room, and sketches a spacecraft without wings or engines because she has read enough to know that space does not need them. That is how this culture changes.
Not with podiums.
With quiet little choices to be curious instead of bored. The strangest irony is that you do not need to pivot to certainty to do something useful with the emotion this story gives you. The same discipline that will make us better at understanding Atlas will make us better at understanding ourselves. When you are faced with something you don't understand in your life, you either build a myth to hide it or a model to explore it. It takes more courage to build the model. It also gives you back more of yourself. Atlas will continue along its improbable path whether our models approve of it or not. It will cross our plane, thread the thin zone where our planets whirl, take the heat it takes from our star, and then it will go. The light will fade the way all lights fade that are not eternities. Somewhere, at some time, someone will put their finger on the page and say, here is where we should have paid more attention, or here is where we finally did. If you are still here, you now know enough to be dangerous in the best way. You know that in March of a year not so far away, in a place built on a volcano in the middle of the Pacific, a machine saw a point of light we have named Atlas. You know that what should have been a plain entry in a catalog became a set of questions sharper than comfort. You know that the two easy stories both feel like lies. You know that the hard story is humble and honest and it asks for your patience. You do not have to donate to telescopes or write papers. You can do something simpler. You can refuse to share cheap certainty. You can ask for sources. You can read beyond the headlines whose fonts are too large to hold nuance. You can keep your sense of humor when people abuse the word anomaly. You can encourage the people around you who do the slow work. It will not feel like heroism. It will be the only kind that matters. The last question in the transcript you never saw but now have lived comes back uninvited. Will we see what this means before it disappears? The answer is not a yes or a no. It is the truth that frightens and frees at once. We will see as much as we are brave enough and disciplined enough to see. If the sky is generous and the schedules align and the funding holds and the weather is kind, we will add to our seeing. If not, we will have been the kind of people who tried. Picture the thing one last time.
Not as a saucer. Not as a comet. As a point. Bright when it should be not.
Quiet where gas should be loud. Falling off in light the way a self-lit thing does when it turns. Skating along a plane that keeps our whole family of worlds in line. That is enough to love. That is enough to study. That is enough to make you step outside tonight into a sky that may give you nothing and give you everything anyway.
Listen to the night.
Not for music.
For numbers.
For the soft sound of a civilization learning to say I don't know yet with the same pride it uses for I was right. For the crisp click of a telescope shutter somewhere on a mountain. For the quiet beat of a human heart that has decided, for once, that awe and rigor do not have to be enemies. For the small promise we can keep even if Atlas yields no answers at all, to keep building an honest map, and to keep walking to its edge. And if the day comes when the instruments tell us something simple and astonishing that the light was made, not borrowed, or that a natural engine we had never imagined can hum inside a stone the way a city hums at dusk, let the moment change you. Let it widen the room. Let it make you gentler with the part of yourself that likes to mock, and stronger in the part that likes to learn. Let it teach you the lesson this object has been trying to teach all along with the only language it owns. The universe is not obligated to fit your taste. It is obligated to be itself. Your job, more beautiful than any certainty, is to watch, to think, and to answer not with fear, not with arrogance, but with a long, patient yes.